Hi everyone and welcome to our Cisco lab. In this lab session, we're going to be doing the simulated workplace assessment number 1 practice for routing and switching. Now, the main purpose of this simulated workplace assessment practice is to get everyone ready for the first simulated workplace assessment for routing and switching. In this simulated workplace assessment, the main topics are Etherchannels, spanning tree protocol, and inter-VLAN routing. So we just basically need to make sure we understand the main configuration commands and the main concepts behind every single one of these protocols. Okay, let's get started. So this activity is a 7-step activity. So we've got 6 steps. There are configuration steps 1 through 6. And the very final step is a troubleshooting step. We just basically need to make sure everything's working. And we also need to make sure that all the devices can ping themselves. We already have some ping tests already being created. They are the 5 buttons on the right bottom side of the screen. And we just basically can execute these tests at the end after we configure every single one of the devices. Okay, so let's get started. So step number 1 is just a simple step to analyze the topology, try to analyze the devices and how they are connected. Now, in the real exam, we're actually going to have the given network topology, and we're going to have to compare the given topology with the packet tracer file. So basically make sure we have all the devices, make sure all the connections are done correctly. In step number 2, we need to do the basic device configuration on every single networking device, including the layer 2 and layer 3 switches, following the requirements below. So we basically have some requirements for the basic configuration on the layer 2 and layer 3 switches. We're going to have to follow every single one of these. So the first one is to make sure all the devices, they have the appropriate host names. The second one is to make sure we have a banner message of the day according to what is given. The domain name on all the devices as well. There should be configured an encrypted password on the console port, which is given. All the passwords, they need to be encrypted globally. All the intermediary devices, they need to be remotely accessible. So we basically need to configure SSH version 2 using a predefined crypto key of 1024. The protocol should authenticate using the local username database. So the username and secret is given to us. And we also need to make sure the unused ports need to be shut down. We need to disable the domain lookup, enable IP routing on the layer 3 switch, and also set the description on the LAN interface of the layer 3 switch to the trunk. Cool. Now, my advice to you guys, because we have to do this on all the devices and we basically have 4 devices, we're going to have to take advantage of a TXT file to create a template with the basic config for all these switches. And then we can basically copy paste the config on all of the switches. That's going to save us a lot of time. So we're going to do just that. In order to do that, we just basically need to have a text editor. Now I'm going to choose to use Notepad because Notepad is already installed on any Windows machine. In order to access Notepad, we can do this with Windows startup key and just type it in Notepad. And we're going to open a Notepad with all the device configuration commands that we're going to type for every single one of the devices. I'm also going to save this file with the name just in case. So everything I do, I'm going to post and put it in the file. Save it as SWA1 Practice in the desktop. And now I can start typing in the commands for every single one of the layer 2 and layer 3 switches. So I'm going to start off with the layer 3 switch. I'm going to use a dash, multiple dashes, just to separate the configurations. This is going to be the switch layer 3. So everything I type below this line is going to be the config necessary for the switch layer 3. And everything I type below the second line is going to be for the first switch, switch 1. We're also going to have switch 2 and switch 3. I can start copy pasting to save time. This is how we're going to separate the device commands that we enter on every single one of the switches. Okay, so let's do the first one, which is the switch layer 3. Now, please remember that when we're doing and copy and pasting the config from a TXT file into the actual device, we need to remember which modes we are in. So if you're one of those people that cannot actually remember the commands and you have difficulty remembering the commands, you can just go to one of the devices and you can use the tab key, the question mark, to help you out remember the commands. And then you can just basically type the commands in your TXT file, and then you can copy paste to the other devices. Now for the switch layer 3, the first thing we need to do is to change the host name. And in order to do that, we have to be in global configuration mode. Now, for us to go into global configuration mode, we need to go enable if we are in user mode. And then typing in enable, we're going to go to privilege mode. Now, in order to do this, we need to be in the global configuration mode. So for me to go into global configuration mode, I can just type it in configure terminal or simply conft. After that, to change the host name is a very simple command. It's just host name. SW-layer3 with all uppercase letters is actual name that is given in the topology. So we basically need to follow the exact same name scheme that is given. After that, we also need to configure a banner message of the day. In order to configure the banner message of the day, we just need to type it in banner, MOTG. Then we can use a delimiter character. In this case, I always like to use the percentage or the $, but it's up to you really. As long as we don't use a character that is going to be used in the statement, there is no problem. Okay, so let's go ahead and use the percentage sign. Now we have to type it in exactly as it is in there, including the spaces. Otherwise, we're not going to get a mark for that. So let's go ahead and make sure we spell it correctly. Unauthorized access is strictly forbidden. Violators will be prosecuted to the maximum extent of the law. And we also need the exclamation mark at the end. Exactly, after we type it in the statement, we can just type it in the delimiter character, which is the percentage sign. Now we can go to the next line. We need to set the domain name, and to set the domain name is just simply the command IP domain name ccna.net. Exactly as it is given. We got to make sure we have no spaces after each one of the lines. Otherwise, the commands that actually need a statement or a word at the end, they are not going to be accepted. Cool. So we make sure there's no spaces at the end. And now we can do the next one, which is the console port needs to be secure with an encrypted password. That should be first security, exclamation, hash percentage. Okay, so let's go ahead and do that. So in order to do that, we first need to go into the console line config with the command line con 0. After that, we can type it in the password, which is first security, exclamation, hash, and percentage. All right. Now, when we type it in the line con password, we also need to type it in the command login to request the password next time. Then we do an exit to leave the line con configuration. And then we can move on to the next requirement, which is all passwords needs to be encrypted if they have already been entered as plain text. So in order to encrypt all the passwords in the configuration, we need to type in the command service password encryption. Let's go ahead and do just that. And now it's done. Our next step is to configure SSH. I'm going to use an exclamation mark here just to help me separate the commands that I enter. Now this exclamation mark, when I copy paste all the commands inside the CLI of the device, the exclamation mark is actually a character that doesn't do anything. So it can just help me out separate the commands. Okay, now let's go ahead and configure SSH. Now to configure SSH, we need to make sure we have a username password pair. And we're going to do that with the command username. Then we type it in the username as given. So the username should be networking. And it says that it should be a secret and not a password. So we're going to type it in secret and then ccn instead of a. All right. We're not done yet with the SSH. Now, one of the requirements for SSH is that we also need to have changed the host name. We already done that. So it's already done. Now that we have a username secret pair, we can just create the crypto keys. And we can do that with the command crypto key generate RSA. Now, when we type the command crypto key generate RSA, it's actually going to ask us for the length of the key in the next line. So we're going to put the length of the key in the next line already, which is 1024. Cool. Now that we have already created the username, already created the crypto key, we have to move on and go into the line VTYs, which are basically the lines that will be accessible via SSH, and say that the transport has to be SSH. Let's go ahead and do just that. Once again, we're going to use the exclamation mark to help me separate the commands. Line VTYs 0 to 15, which is usually the amount of VTY lines that we have on switches. We're going to type it in transport input SSH. And then for SSH configuration on the line VTY, we also need to type it in login local so that SSH will be using the username password pair that we have just created in the local database. We're going to go ahead and type it in login local so that the local database will be used. After that, we don't have to do anything else on the lines anymore. We can exit the lines and then we can change the SSH version to version 2. Type in the command ipssh version 2, because according to the requirement, we need to have SSH version 2 running. Done. I can use an exclamation mark here once again to separate my commands. We can move on now to the next step. Now, the next step says we need to turn off all the unused ports. I'm not going to do that right now. I'm going to leave these at the end, only if necessary. So I'm not going to do it right now because I want to make sure everything is going to be able to ping, and I don't want to turn off the ports accidentally, the ports that I will actually need. Cool. Now let's disable domain lookup. In order to disable domain lookup, it's a very simple, intuitive command as well. It's the command no IP domain lookup. So that just basically means when I type it in a command that the router or the switch doesn't understand, the switch will not actually try to find out an answer for the misspelled command. It will just say that it cannot find the command. We can move on to the next step. If it's a layer 3, we need to enable IP routing. To enable IP routing on a layer 3 switch, it's a very simple step. The command is IP routing. This command will basically tell the layer 3 switch to start understanding packets, to just basically start acting as a router and start forwarding packets. Awesome. Now, our final step for the layer 3 switch is to set the description to dtrunk on the port that connects to our local area network. In that case, it's gigabit port 000. We're going to do just that. So interface gig 000. And then we're going to type a description. And the name is dtrunk. So once again, we have to type exactly as it is given. And that is all. Now, before we actually use the same config to deploy to all the other switches, we want to make sure these commands, they will be accepted. We want to make sure there's nothing wrong with these commands. And the easy way to do that is just basically by grabbing all the config. So we can do a Control-C from here, or we can just click right, copy. We're going to go to the device, layer 3 switch, CLI. And from here, we first need to hit enter before we paste the config, and then we can click paste, or we can just do a click right, okay, on the CLI. So let's go ahead and click paste. And now we can just basically verify if all the commands have been accepted. As we can clearly see, most of them have been. There are no errors after the command themselves. However, in the very final one, invalid interface type and number, there's just basically an issue. It's not gigabit 000, it's gigabit 01. So it also allows us to find out if we did something wrong. Let's go back and fix this issue. It's gig 01. Now I can just basically copy paste just this part again. There's the switch, paste, and now we've got the correct command. Now we'll be able to see that now we've got 5% completion, which is good. And now we can basically grab all these config and use it for all the other switches as well. Now, before we start using the config for the other switches, we can go ahead and check results and see if everything that we did in the switch layer 3 is correct. I'm going to go ahead and collapse all. I'm going to expand the network, find the layer 3 switch. The banner is correct. The IP domain is correct. The security, the modulars, which is for SSH, is correct. The VTY lines have been configured correctly. And that's pretty much all that we have done so far. The SSH version has been configured correctly. The console line has been configured correctly with correct password. That's just basically everything we did on the layer 3 switch is correct. We're going to use the same config that we did for the layer 3 switch. So we're going to start copying and pasting, and we're going to make the necessary adjustments on the other switches. Paste here for switch 1. Let's do switch 1. What are the things we need to change on switch 1 config? We need to change the host name. It's not going to be layer 3 anymore. It's going to be switch 1. The banner is still the same. The main name is still the same. Line call the same. Password the same. Pretty much everything is the same. The basic device config is the same, except that now we're not doing anything in the interfaces yet of the switch. I'm just going to delete that. Now, because it's a layer 2 switch as well, it's not going to be able to accept the IP routing command. I'm also going to remove it. And now we are ready to use the same template of the layer 2 switch 1 for all the other switches as well, including layer 2, switch 2, and layer 2, switch 3. Let's go ahead and copy and paste this config for the layer 2 switch and for the layer 3 switch. But the only thing that we're going to have to change now is the hostname. So on switch 2, it's going to be hostname switch 2. Everything else stays the same, including the SSH config. And on switch 3 as well, we have to change the hostname. I can go ahead and save my config file, my txt file, just to make sure I have it if something goes wrong. I'm going to go ahead and start copying and pasting the config on the layer 2 switches. Let's go ahead and start with switch 1. So it starts in enable, and it go ahead all the way down until a little bit before switch 2. Let's go ahead, go to switch 1, CLI, click in the CLI, hit enter, and then we can paste the config. Let's see if everything's correct. Hostname is correct. It accepted the SSH commands. It accepted everything else. It's all good. Right? Now we can go ahead and do the same for switch 2. I'm going to go ahead and grab the switch 2 config. Starts here all the way down to here. Click on switch 2, CLI, paste, and we're pretty much done with switch 2 as well. We're already at 20%. Awesome. Let's go ahead and do switch 3 now, which is the last one. Control C, switch 3, CLI, click on the CLI, hit enter, and then paste. Now we're pretty much done with the basic device config on all the devices. Now we can move on to our major step number 2. And close this. In our step 2 now we have to, no, we just completed step 2, sorry. Now let's go ahead and go to step 3. Assign the IP addresses to the interfaces according to the table below. We just basically have to set some IP addresses on the appropriate interfaces. Please note that the switch layer 3 doesn't have physical interfaces with IP addresses. We only have IP addresses for the interface VLANs, which are going to be the gateway addresses for all the client machines. We also do have SPIs on the switch 1s. We also do have that all the client machines, they need to have the first IPv4 available address, and the default gateway address needs to be configured on the switches to enable remote management, and all the VLANs, they have to be created with their names. We have to assign the appropriate VLANs to the correct access port on switch 1, 2, and 3. So we're going to do just that. Now, before we actually start assigning the IP addresses, let's assign the IP addresses on the client machines as it is required. So let's go ahead and start with PC1. PC1 is part of VLAN 1. I'm going to click on PC1, desktop IP config, and we're going to configure the IPv4 address on PC1, which is 192.168.1.1 as given. Now, it is not exactly given to us, but it said that we should use the first available address. Now, VLAN 1 is part of 192.168.1. Look at the subnet mask here for VLAN 1. It's actually a /24. For /24, the first available address in this case will be .1. Now, we can hit tab to use the default subnet mask because these are all class 4 addresses, so they belong to a certain class, class C. They're all going to be /24 networks. After that, we can assign the default gateway, which is going to be 192.168.1.254, which is the very last available address, and also the interface VLAN IP address on switch layer 3. Okay, we can do that for all the other devices. Now we are at 28%. Go ahead and do PC2. 192.168.2.1. 192.168.2.254. For PC3 as well. 192.168.3.1. 192.168.3.254. For PC4. 192.168.4.1. 192.168.4.254. Now let's go ahead and do the laptop as well. Desktop IP config 192.168.10.1, 192.168.10.254. We're pretty much done with all the PCs and laptops. Now we're going to go ahead and do the same for the server because we also need to configure the server. IP config 192.168. Now for the server, it's VLAN 90, so we're going to type it in 90.1. The default gateway is 90.25. I'm going to close it. And now we're going to move on to the next step. We have to configure IP addresses on the layer 3 switch and also on the layer 2 switches as well for the management VLAN. So let's go ahead and do that. I'm also going to do these steps in my TXT file. Now let's go ahead and start doing the first one, which is basically creating the interface VLANs on the layer 3 switch. Now, before I actually start creating the interface VLANs on the layer 3 switch, let's go ahead and create the VLANs and assign a name to the VLANs before we actually do that. All right. So let's go ahead and do that. In order to create the VLANs, we just need to type the command VLAN and then the VLAN number that we want to create. VLAN 1 is already created, but I'll just type it in. Doesn't really matter. Now let's go ahead and assign a name. Now, one observation here is that even though I can type it in here in my txt file, and even though I'm going to be able to copy paste, we're actually going to get a warning because VLAN1 cannot be deleted and VLAN1 cannot be renamed. All right, but it doesn't really matter. We can still type it in. VLAN1 was supposed to be red. VLAN2 has a name as well, which is yellow. Just following the topology. We also have VLAN3, which is named green. Please note that they are all uppercase letters according to topology. This is all case sensitive, so make sure you type it in accordingly. VLAN4, name blue. VLAN10, name gray. And we also do have VLAN90 and VLAN99. Now, please note that we don't actually have the names for VLAN90 and 99 in the guidelines. Now, this was actually a mistake. In the actual exam, we are going to have the names for VLAN90 and 99. Now, we are going to use servers for VLAN90 and management for VLAN99 because VLAN99 is used for management and VLAN9 is used by the servers. Let's go ahead and type servers for VLAN90 and management for VLAN99. All right, done. We have created all the VLANs. Now we can actually start assigning the IP addresses to the interface VLANs on the layer 3 switch. So let's go ahead and do just that. Interface VLAN1 on the layer 3 switch will have the IP address of 192.168.1.254. The subnet mask is the /24 32550. And then we can do a no shut just in case to make sure the interface is going to be up. And then I can take advantage of this to copy, paste, and create all the other interface VLANs and assign the appropriate IP address. Go ahead and do just that. It's going to be VLAN 2, 2, 3, 3, 4, and 4. We also do have 90, 9254, and we also have 99, which is 99 in here. And that's all. So after these two steps, we're going to have created all the VLANs on the layer 3 switch. We're also going to have created the interface VLANs. Right. Now we can take advantage of these commands that we use to create the VLANs and do the same for all the other layer 2 switches. I'm just going to copy and paste this on all the other switches. On switch 1, I'll also have to create the VLANs, name them. On switch 2, I'll have to create the VLANs and name them. On switch 3, I'm going to have to create the VLANs and give them a name. Right. This is exactly what we're going to have to do. Pretty much done. Now for switch 1, switch 2, and switch 3, we also have to create the interface VLAN 99. Now with this, the VLAN has been created already. We need to assign an IP address for the SVI, which is going to be used to manage the devices. Let's go ahead and start with switch 1. Interface VLAN 99. The IP address will be 192.168.99.1. 552.5.5.5.0 is the subnet mask. Then we can do a no shut just to make sure the interface will be up. I can close that set of commands with an exclamation mark. Now let's go ahead and do the same for switch 2. I'm going to copy paste to make my life easier. Now it's going to change the IP address for switch 2 is .2 instead of .1, and for switch 3 is .3 instead of .1. Right? So we're pretty much done now. We still need to do one more thing in step 3, which is assign the appropriate VLANs to the correct access port on switch 1, switch 2, and switch 3. So that just basically means every single one of these ports that connect to the end devices, they need to be in their appropriate VLAN. Now, because we're already here, let's start with switch 3. So I'm already here, switch 3. We're going to go ahead and type the command necessary to do that. Now, if you guys recall, we just have to go to the interface configuration. So interface FA01 according to topology, and we need to assign it to VLAN 10. First, we need to make the port an access port with the command switch port mode access. And then we can assign it to a VLAN with the switch port access VLAN 10, okay, which is the corresponding VLAN for the specific port. I'm going to copy paste this for all the other devices. I'm going to copy this, go ahead and go into switch 2. Now for switch 2, it's not fast Ethernet 01, it's actually part of VLAN 1. So I can just change that here. And I can use this for all the other ports. So I'm going to copy and paste right below. Port 2 belongs to VLAN 2. Port 3 belongs to VLAN 3. And port 4 belongs to VLAN 4. And we're pretty much done with switch 2. Now I can go ahead and go back to switch 1. Now please note that switch 1 has actually just one access port, which is the one that connects to the server. So let's go ahead and paste. I will still have it pasted here. So interface F, which interface is this? So this is actually the gigabit. Now we're not very sure if this is actually 01 or if the top one is 01. So let's go ahead and check. I'm just going to unconnect here from the switch side. This was actually gigabit 02. So this is actually gigabit 02, the one that connects to the server. The one that goes up to the layer 3 switch is the gigabit 01 on switch 1. So what we actually need to do is the gigabit 02, which is the one that connects to the server, needs to be an access, and it needs to be in the same VLAN as the server VLAN, which is 90. Now I can still use the exclamation mark just to separate the commands. Now I can go ahead and save my file just to make sure. And we're pretty much done. Now we have typed the commands. Now it's just a matter of applying the commands. If you like to just type the commands straight away into the devices, you can do that. If you don't, you can just paste them later after you make sure they are correct, after you confirm that they are what they're supposed to be. So let's go ahead. These are the commands that I still have to paste into my layer 3 switch, beginning in the VLAN creation all the way to the interface VLANs. I'm going to do a Control-C, go to my switch layer 3, and first we have to go ahead and type the password, which is 1ST, first security, exclamation, first. All right, now let's go ahead and copy the config. Now, please note that I was in global config when I started creating the VLANs. So I have to go back to global config before I paste the VLAN commands. I'm going to paste them here. Let's go ahead and confirm. So all the VLAN commands have been accepted. And the interface VLAN commands have also been accepted. And now we do have many interface VLANs created, and they are all up. Right. Let's go ahead and hit enter. And now we're going to copy paste the rest of the config on the other devices. So for switch 1, same commands. So VLAN 1 all the way down here. Let's confirm this is switch 1, yeah. So I'm going to copy paste again, go to switch 1, CLI, make sure I am in global config. So I have to log in here again. If you think that this process is not that great, you can actually assign the console password only at the end, and that's going to save you the need to always type it in before you copy paste config again. Okay, so let's go ahead and paste. Let's confirm that all the VLANs have been created. Now we can also verify that the VLAN database is correct with the command do show VLAN brief, we're going to be able to see that all the VLANs have been created accordingly. Please note that even though I try to change the name on VLAN 1, it didn't actually work because we are not allowed to do that. Okay? Because VLAN 1 is the native default. It's the default and it's the native by default. All right, cool. So switch 1 is done. Let's go ahead and check switch 2. We created the VLANs and we've also assigned to their specific ports. I'm going to copy and paste this into switch 2. Enter. First, security, exclamation, hash, percentage. Enable conft and then paste the config. Once again, all the commands have been accepted. VLAN 99 is now up. And we can now go ahead and do the same for switch 3. VLAN 1 all the way down to when I assign the port to the appropriate VLAN. First, security. Enable conft, and now we can paste the config here. We're pretty much done now. We're already at 62%. Now let's move on and finish the exercise. So we're done with step number 3. We have assigned the IP addresses to the interface VLANs on the layer 3 switch. We have assigned the SVIs on the layer 2 switches according to the table as well. We have assigned the IPv4 address on all the client machines. We have assigned the ports to the appropriate VLAN. We have created the VLANs and named them according to the topology. And we have made sure that the VLANs are correct. Okay, now let's move on. It's now step number 4. We have to now configure the Etherchannel link between all switches following the table. Now, this table will basically tell us the channel group, the switches that participate in the channel group, and the protocol that I need to configure for the Etherchannel. So for channel group 1, which is just basically this one on top, which connects switch 1 to switch 2, it uses port 05 to 06 on both switches. Switch 1 will be in active and switch 2 will be in passive. These are basically the two modes that we can have using the LACP protocol. For PAGP or the channel group 2, we have the same, and the channel group 3 is a manual Etherchannel, so both sides are on. Once again, we're going to do this in the TXT file to save us time. So the first step, let's start with switch 1. So we're going to begin with switch 1. Okay, right after my final command, now we're going to start configuring the ether channels. In order to configure the ether channels, we basically need to select the range of ports that are part of the ether channel. So just type it in the command interface range and the ports that are part of the ether channel. In this case, for channel group 1, it's 05 to 6. So after I'm in the interface configuration mode for these two interfaces at the same time, I need to make the ports trunk ports before I'm actually allowed to configure the ether channel. So we do that with the command switch port mode trunk. All right. And then we need to assign it to the channel group. And we need to assign the mode. Now remember that the mode will dictate the protocol. In this case, we're using LACP. So the only two possible modes would be active or passive. On switch 1 will be the active and switch 2 will be the passive. Right. After this, we can do a no shut to bring the interfaces up. And then we can do an exit, exclamation mark again. And that's all we need to create the port channel on switch 1. Now the port channel or the ether channel hasn't been formed yet because I need to do the same on the other end. All right, so I'm going to copy paste this because this will apply to switch 2 because switch 2 is the other end of this channel group 1. I'm going to copy paste this config to my switch 2. All right. Now it's still channel group 1 because it's the other end of it. The ports are still the same that are part of it. And we still need to change to trunk before we actually configure the channel group. Now, please note that for switch 2, it's not active anymore. It is passive. So So I'm just going to change this to passive, and that's all we need to do. All right. Channel group 1 is pretty much done. All the config that I need to form channel group 1 is done. Now let's go ahead and form channel group 2. Please note that for channel group 2, switch 1 does not participate, so I don't need to type anything on switch 1 for now. I actually go ahead and type on the switch 2. I'm already in switch 2, so I can start typing the commands. The interface range now is 7 to 8 for the ether channel. We still need to change the switch port to trunk. And we still need to change the channel group. Now it's not channel group 1 anymore, it's channel group 2. And now the mode is desirable because it's now using PAGP. After that, we can make sure the interfaces are up with the no shutdown command, and we can exit the interface config. So pretty much all we need to do on switch 2 for the both ether channels that switch 2 participates is already done. Right. Now, please note that the other end of this channel group 2 hasn't been configured. We need to go ahead and go to switch 3 to do that. I'm going to copy paste channel group 2 config into my switch 3. The ports are the same. Switch port mode trunk still needed. And the channel group is still 2, but the mode is not desirable anymore. It's auto on switch 2. On switch 3, sorry. Okay. Switch 3 also participates in the manual ether channel, and because I'm already here in switch 3, I'm going to do that. So interface range for the manual ether channel on switch 3, fast Ethernet 09 to 10, switch port mode trunk. Channel group is not 1, it's not 2 anymore, it's actually 3. And the mode is on because that's going to be a manual ether channel. Make sure the interfaces are up and exit. All right. Now, the only thing we haven't done is the channel group 3 on switch 1. Let's go back to switch 1 because we still need to do that. So interface range FA09 to 10. Switch port mode trunk, channel group. In this case, the channel group is 3 and the mode is on. No shut to make sure the interfaces are up, and exit, and exclamation mark to separate the commands. See that with the exclamation mark, it's actually much easier for us to identify what set of commands is doing what. Okay. So it's strongly recommended to use the exclamation mark if you're using the txt file for the config. All right. So now we have all the commands that we need to create the ether channels. We're going to start copying and pasting the config to their appropriate switches. So this is switch 1. I have already copy pasted the interfaces all the way to here. I've already copy pasted. Now I still need to copy paste the ether channel config for switch 1, which is all of this. So I'm going to do Ctrl+C, go to my switch 1, CLI, already in config, paste, and we're done with switch 1. Go ahead and grab the switch 2 config for the ether channels. Copy, Ctrl+C, exit, being global, paste. That's it for switch 2 as well. Switch 3, the channel config is this. In my switch 2, switch 3. You can clearly see we are in switch 3. That's it. And we paste here. Okay. We're now at 84%. Just have to do a few more steps and we are done. Let's go ahead and do just that. Now we need to configure the layer 2 spanning tree protocol. Now all the ether channels there was supposed to be operational. However, we still need to configure spanning tree protocol on the switches. So we need to make sure all the switches are running rapid PVS C+. We need to configure the Portfest on the active switch ports connected to endpoints. We need to configure BPDU guard on switch ports that you have configured to be Portfest. We need to make sure switch 1 is the root bridge for VLAN 1, 2, 3, 4, 10. Switch 3 needs to be the root bridge for 90, 99. Switch 1 is the secondary root bridge for VLAN 90, 99. Please note that when we configure the switch 1 to be the secondary root bridge, we need the command root secondary, and switch 3 will be the secondary root bridge for VLAN 1, 2, 3, 4, 10. And we also need to use the command root secondary. So we're going to do just that. So we're going to go to switch 1 first, and we're going to do all the spanning tree configuration on our switch 1. Go back to our txt file. Let's go back to where we were doing switch 1's config, which is right here. Okay. Right after we create the ether channels, we can start configuring the spanning tree. Now, after these exit here from the interface, I'm back to global config. From here, I can start configuring spanning tree. Now, in order for me to enable rapid PVST+, that is a global command. It needs to be done in the global config. Command is spanning tree mode rapid PVST, and that's how we enable spanning tree mode rapid PVST plus on the switch. I'm going to separate this command from the others. Now we also need to configure all the switch ports that are connected to endpoints. They need to be in Portfest, and they need to be with BPDU guard enabled. So we're going to do just that. The interface that is connected to my server, remember, we're still doing switch 1, is the gigabit 02. Okay? Gigabit 01 is the one that goes to the layer 3 switch. So interface gig 02 of my switch 1, I need to enable spanning tree Portfest. The way I do that is with the command spanning tree Portfest, and that's all. We also need to enable BPDU guard. The command to do that is spanning tree BPDU guard enable. And then we already have changed the switch port mode to access, and this port already belongs to VLAN 90, so we don't need to do anything else. All right, cool. Now there's one more thing we still need to do in switch 1. Switch 1 needs to be the root bridge for 1, 2, 3, 4, 10. And it needs to be the secondary root bridge for 90, 99. How do we do that? It's a fairly simple step with the command spanning tree. And then we specify the VLANs that we want to change the priority. Remember that the fact that a root bridge will or not be the root bridge is related to the priority. The lowest priority wins, and that's exactly what we're going to change. For switch 1 on VLANs 1, 2, 3, 4, and 10. Which one will be the root primary? Okay. And for the other VLANs, 90 and 99, switch 1 will be the root secondary. Right. Cool, we're pretty much done with switch 1. We now need to do switch 3. Okay. But please remember that we still need to enable rapid PVST on switch 2. We don't need to change the priorities on switch 2, but we still need to enable rapid PVST plus on switch 2. So let's go and do switch 3, because we're going to have to change the priorities. I'm going to take advantage of all of this. So I'm going to copy paste into my switch 3. Now, please note that for switch 3, we don't have the gigabit 02 that we're going to have to change to Portfest and BPDU guard, but we have to do it on the ports 1 all the way to 4 on switch 2. Okay. Now, on switch 3, we just need fast Ethernet 01. I'm going to change gigabit 02 to fast 01 on switch 3. Remember, we're still doing switch 3. Okay. So on switch 3, it's going to be the fast Ethernet 01 that will need to have Portfest and BPDU guard enabled. All right. Now, this is going to be the complete opposite. Now, switch 3 will be primary for 90 and 99. So it's just a matter of changing this, okay, swapping around, and we're pretty much done. All right. So fast Ethernet 01, which is the one that connects to the laptop 1, will have Portfest, will have BPDU guard enabled, and will be the secondary root bridge for 1, 2, 3, 4, and 10 VLANs. And it will be the root primary for 90 and 99. So we're done with switch 3. We can go ahead and do switch 2. Remember that switch 2, we are going to have the same thing. So I'm just going to paste my spanning tree config. So spanning tree mode will also need to be rapid PVST. The interface that needs to be Portfest and BPDU guard enabled are the interfaces 1 all the way to 4. So I can take advantage of the range keyword and use 1 to 4. They will all be Portfest. They will all have BPDU guard enabled. Now that's all. We have just now finished configuring the spanning tree protocol. Now we can start pasting the config on the appropriate switches. Let's go ahead and start with switch 1. So once again, switch 1 has gigabit 02 connected to the server. It needs to have Portfest and BPDU guard enabled. This is what we've done. And it will be root primary for 1, 2, 3, 4, 10, which is exactly what is asked from us. And the root secondary for 90, 99. Let's just replace these 94, 99. 90 and 99. And now that we're pretty much sure we've done the correct thing, we can now copy paste this spanning tree config that we did on switch 1 into switch 1. Paste. And now we can copy paste the config on switch 2 and switch 3. On switch 2, it's all of this, all the spanning tree config. Paste. Right. And now we do switch 3. All of this. Control C. Go into switch 3. And paste the config. We're now at 90%. We still need to configure interVLAN routing and then do the tests. Let's go ahead and do just that. Now it's step 6, configure interVLAN routing. Configure the link between switch layer 3 and switch 1 to be a manual trunk. As we can clearly see here, this is actually down. We still need to configure this link. Let's go ahead and go to our switch 3 and see why this is still down. Go into switch 3. First, security. Enable. Let's show the interface, show IP interface brief, and see why that interface is down. So it's gigabit 01. As we can clearly see here, it's administratively down. We need to bring that interface up, and we also need to make sure that interface has been configured as a trunk. Okay, so let's go ahead and do just that. Go interface gig 01. Make sure it's up, so no shut. All right. And we also need to make sure that this interface is a trunk. So we need to type in the command switch port mode trunk. We're going to get a warning because all the layer 3 switches in Packet Tracer, we actually need to change the encapsulation, okay, before we are able to make them a trunk port. To change the encapsulation is a fairly easy process. It's the command switch port trunk encapsulation. Now the options are .1q, okay, and that's exactly what we're going to do, .1q. We're pretty much done. On the oldest versions of the iOSs and on the physical devices, we not only have .1q as an option, but we also have ISL. ISL is a legacy technology. It's not used much. It was created by Cisco. It's pretty much dead because pretty much everybody just uses .1q instead. Okay, now we're pretty much done. All these commands that I have just typed in here, I'm going to type it in my TXT file as well, just for me to have it as a record. Okay, so we went into the layer 3 switch, interface gig 01. So the first thing that we did was bring the interface up, and we changed the encapsulation before we were able to change the trunk. Otherwise, it won't let me do it. And then we changed to switch port mode trunk. And that's all we did in our switch layer 3. We're now at 91%. Let's see what else we still need to do. So configure the links between layer 3 switch and switch 1 to be a manual trunk. Now with this command on this interface of the switch layer 3, we're still not sure if it's a manual trunk. We need to check if gigabit 01 of switch 1 has been configured as a manual trunk as well. Let's go ahead to switch 1 and check it. So interface gig 01, switch port mode trunk. Yep. So now we have just created the manual trunk. Now make sure the native VLAN on this trunk link is 1 in order to verify that we can do show interface trunk. And this will basically tell us the interfaces that we have that are trunk and also the native VLAN. And check it out, we also do have port channel 1 and port channel 3 using 802.1q encapsulation, and they're all in trunk mode as well. Awesome. Now let's see what else we have to do. Configure 802.1q encapsulation. Make sure the SVIs on layer 3 switch that you configure in step 3 are enabled. Verify the routing table in the switch layer 3 to ensure all interfaces are participating in the routing process. I'm going to click into my switch layer 3. Exit. We're going to do show IP route. And we're now able to see all the interface VLAN network addresses. That basically means that our switch layer 3 now understands about all the networks that we have based on the 802.1q encapsulation. That just basically means my layer 3 switch is now going to be able to do the routing. All right. Cool. We still have one more step here. You need to ensure that connectivity has been established. Please do the following tests. So all the pings have been pre-configured. They're all here with the fire button. Let's go ahead and fire the packets and see what happens. Let's see if we got anything which is successful. Sometimes we actually need to run the test twice. As we can see, none of the tests are yet successful. So we just basically need to fix something. Right? Now let's check the requirements. If any of the tests fail, make sure you troubleshoot the network. Now it's yet not working. Let's go ahead and do the next one, and then we come back to troubleshoot what's going on. The very final step is that there's a massive bottleneck in the communication with the server. Inspect the connection between switch 1 and make the necessary updates to make sure the link is optimal. Now, if you just go ahead and click on the connection from the switch 1 to the server, and we try to plug again the Ethernet cable, we actually have two options for the interface on the server. We have fast Ethernet 0 and we have gigabit 1. Now, for an optimal communication, we actually need to connect to the gigabit port 1 because the other end of the connection is connected to the gigabit port of the switch. So to make sure this is operating at the optimal speed, we need to make sure both ends are connected to a gigabit port. Now, if I click on my server, the IP config that I did before was on the fast Ethernet. Now, what I need to do, I need to change to gigabit Ethernet and use the same IP address config. Now, before I do that, I'm going to erase this because otherwise it's going to tell me an error. It's going to give me an error because I cannot configure the same IP for multiple interfaces. Now that I have erased the IP config on the fast Ethernet, I'll change to gigabit. And now I can type it in the commands. So for the server is 192.168.90.1 and the default gateway is 92.54. We're going to get a warning saying that packet tracer will use the default gateway of the fastest functional port, which in this case is the gigabit port. I'm going to click OK. And now we're pretty much done. We can now investigate why we still haven't got 100%. We can now investigate why there's some errors in the pings. So let's go ahead and check results. Assessment items. Collapse, show incorrect items. So we've got a wrong default gateway on switch 3. we've got a wrong IP address on VLAN 10 on the layer 3 switch. And that's pretty much all. All right. So we're going to fix that. The first thing we need to do is define a default gateway on switch 3. I'm going to go back. Switch 3. In order to assign a default gateway for a switch, I just need the command IP default gateway on the switch, and then type it in the address of the gateway. Because we're using the SWA 99 on all the switches, the gateway needs to be in VLAN 99 as well. It's the 254 IP address, which is the interface VLAN of the switch layer 3. Enter, that's all. Once again, I'm going to put it in my txt file just to see exactly what I have done in the end. So we're pretty much done with the default gateway now. There's one more mistake, which is the IP address on the layer 3 switch. Let's go to our layer 3 switch and see what's wrong. Do show IP interface brief will allow us to check the interface IP addresses. And we can clearly see the error here. And the error is that we basically skipped VLAN 10. So we're going to have to create VLAN 10 as well. I'm sorry, guys, that we don't have a VLAN 10 on the network. It was just, in the end, it was just a mistake with the VLANs. All right. I'm just going to create VLAN 10 here and assign a name to VLAN 10, which is great. Oh, yeah, it's here. VLAN 10 is actually here. It's the gray VLAN. When I was typing in the commands, we've actually forgot to type it in VLAN 10 on the layer 3 switch. Go back. Yeah, so we created all the interface VLANs except the 10. In order to fix this, very simple. Interface VLAN 10, and the IP address would be 192.168.10.254. And a no shot. Now we can copy paste this into our layer 3 switch. Make sure everything's going to work. And now we're done. We have one more interface. Let's go ahead and check to show IP route. And now we have VLAN 10 right there in the routing table. It means my VLAN 10 machine will be able to communicate now. All right, let's go ahead and check our results. The activity is still incomplete because we still need to do the connectivity test. Go back. Do the connectivity. Oh, they're done automatically. We don't even need to click again. They're now all successful. We're now at 97%. Let's check the result. Show incorrect items. We got nothing incorrect. Everything's fine. We have some incorrect priorities configured on VLAN 2, 3, 4, and 90 of our switch 2. Now, we are not actually required to change the priority on our switch 2. Let's go back and check. Switch 2. Yep, so we were not supposed to change the priority on switch 2. So let's go back to our txt file and see what we did wrong. And here's our problem. The problem is that when we copy pasted the priorities, we actually copy and pasted the root primary and root secondary on our switch 2 as well. So in order to fix that, we're just going to do a no, because we don't want that in switch 2. It's supposed to be only on switch 1 and 3. Let's go ahead and copy and paste this into switch 2. First, security. Enable conf D and paste it. And now we've got 99%. Let's go ahead and see what else is wrong. Check results. Incorrect items. I'll see that way. So let's investigate. Everything seems to be fine. Sometimes packet trace takes a while to reach the 100%. Let's go back. All the tests are fine. There's still a priority set on VLAN 90 of switch 2 that we need to remove. Okay, yeah, this was supposed to be 99. Before I type it in no, I'm going to copy paste again. Go back to switch 2. No spanning tree VLAN priority. Check the results. Got a few issues with switch 2 priority. Let's go back to switch 2 and see why it's giving us that error. Now we can do a show run on switch 2. And this is why it's still giving us an issue. The priority is set to 28,672. I'm going to remove that with copy paste. Copy. Go to the txt file. We need to remove that. So no. Copy and paste this here on switch 2. And now we are at 100%. Okay. Cool, guys. We have completed the activity. Now I've got a few tips. So I was able to complete the activity in 1 hour. That's why I'm actually telling you guys that you've got 2 hours to complete the assessment. Now, there are some benefits, huge benefits of using the txt file. But just like you guys have seen as well, if we don't be extremely careful with what we are copying and pasting, we might copy things from one device into another device that was not supposed to have that config. And if we're copying and pasting, of course, it's going to be faster. Of course, it's going to be quicker. However, we need to make sure we are copying and pasting the correct things. Okay. Now, that's pretty much it. If you guys still have any questions about these assessments, feel free to contact me or Sam. Send us a message, and I'll see you guys next week for the real assessment.